Hey everybody, this is Larry. This is me doing the premium weekly question for week 4. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this poem. I forgot it in the other video, but happy Chinese New Year, happy New Year, happy Lunar New Year, whatever you want to celebrate. I'm here for you. Today's poem is 1088, or this week's poem is 1088, confusing number 2. I wonder if they did the 88 on purpose, like lucky Chinese numbers. But yeah, a confusing number is a number that when rotated 180 degrees becomes a different number with each valid digit. Okay. We can ignore any zeros. Okay. Return the number of confusing number in the range of 1 to n. What is n possibly? N is 10 to the 9. That means that we are going to have to... That means that this is going. We have to at least think about it a little bit. I guess this is a hard problem. So the tricky thing is that it has to be a different digit, right? A different number, right? And what I mean by that is that 88, for example, is a, or maybe just even 8 is not a good one, right? Because 8 and 88 and so forth. But and even like 888, 818, right? And 8118, 888, something like that, right? So first of all, we can first convert it into 5-digit number because this is so annoying to do. But you can consider it up to 5 digits, right? Because and n is kind of annoying, but and then after that, we can think about it a little bit. Because leading zeros are okay for some reason. There's 19 and 100. Yeah, this is not a problem that I can do quickly. But that's really behind that idea, and then it's just about counting them in a smart, intelligent way. For example, 6s can go with any of the other numbers, right? 168, but not 9. Okay, so 69 cannot be good for this one because it rotates, and also 96. So this becomes actually a different problem, right? It becomes a 5-digit problem, which you can figure out very quickly. Or a based 5 problem, a based 5 problem, which you can figure out very quickly about how to count, relatively speaking. And then you have to subtract the ones that are kind of that you can do. That is the same number backwards and forward, right? And basically, what are the numbers that are good forward and backwards? So we have all these things. I think that's all of them for 8s and maybe 1s. So that's kind of a little bit tricky. So there's 1, there's 1 1 as well, and then like 1 1 1, 1 8 1. So, and to add to the confusion or difficulty, there's all, and I didn't even enumerate all of them, obviously. But even then, the trick is that so there's 69 as well, 619. The idea is the same idea that but this is such an annoying problem to do when I'm trying to sleep early. I made a mistake maybe on trying to do this. But if you can enumerate these, then the other one is just going to be base n, and of course you can't go all the way 10 to the 9, but yeah. I'm trying to think what is a clean way of implementing it. Like, it's not difficult, it's just that there's a lot of stuff, right? It's basically the same idea as kind of doing a palindrome, to be honest. In that you take half and then you maybe take a middle number, and the only 3 numbers that could be in the middle, 0, 1, and 8, right? Middle is equal to 0, 1, and 8 maybe, and then other is equal to 6 and 9, right? And then and I just kind of combine them in a weird way. And this is middleable. But actually that's not bad, because if it's 10 to the 9, right, that means that you could do 10 to the 5th iterations every other, so then you can kind of brute force check all of them, and that's pretty much the idea, I think, right? Okay. This is annoying to implement, but not a big deal, maybe. Basically, okay, so for I is in range of, say, 9, for example. This is the number of digits. So actually, yeah, maybe digits is this, right? So if digits is, mod 2 is equal to 0, if it's even, then we can take, yeah. And it can only go up to 100,000. That should be fine. Yeah, okay, fine. Let's do it that way. I don't know if it's going to be fast enough just because of the Leetcode thing, but there are other optimizations that we can make. But yeah, so let's just say rather same is equal to set, maybe. Yeah, maybe. Right. Then yeah, for this is so annoying to write. I mean, it's not even hard, it's just annoying. I'm just kind of too exhausted to kind of think about how to optimize this in a good, or how to write it in an optimized way. Such a weird, annoying problem. This is like doing admin of code at midnight. Should have done it earlier. Oh well. So if it's even, then we can take all of these, right? That's fine. We could generate them. I worry that it'll be too slow, but maybe that's fine. It only, yeah, only. Let's go ahead, generate digits, and then here we want middle plus other, right? And that's fine. And actually, it's digits over 2. Oops. Actually, we could generate them from like almost in a dynamic programming kind of way. So maybe we can do it that way. Right. So yeah, maybe we could do it that way, right? So let's just say rotatable, maybe that's what I meant. Is to go to we started off by having a middle, right? And then we add a digit, maybe. Yeah. Okay. So now we're starting with 2 digits because it's already have 1. This is so exhausting to think about. Whatever. So let's just say this is 1 digit is equal to and then maybe this is just also silly the way I'm doing it sometimes, to be honest. But okay, so then now, right? So now if we're adding a, this is already this is 1 digit, and then for even digit, this is also true. So we don't really need to do it, right? We just basically take that number and then palindrome it, right? This is just so annoying. Okay, so 1 digit is this, and then now 2 digits. It's gonna be basically middle plus other, really, right? And then now for each of those digits, we kind of calculate the whatever. Right? Yeah, I think so. And then this is just equal to for each of this number, we kind of just add the middle to it. Something like that, right? Is this going to print what I think it prints? Let me double check real quick. I guess we're going to return 5 or something. All right, so 018, 0186, 018. Oh, because of the leading 0. But otherwise, it is kind of what we want, other than the leading 0. Yeah. Okay, so that is basically what we want, because then now we just add, this is one, this is actually 101. This also is maybe not quite right in that. The leading 0 thing is a little weird. But yeah, okay, so then this dupes, and then 3, and then and then 4 is also just the third one, right? Just another case. Not anymore. And then 5 digit is just same as this, but okay, so 4, is that right? Am I missing anything? 16? No, it's something missing, like for 4 is this, but it also adds like now 16 can be the middle, right? I think that's the problem, is that this is actually this, but it's this plus other. Okay, maybe this is more right. Yeah, and then we duplicate it. And then, yeah, that makes sense now. Okay. Right. I am a maniac. And then 6 digits is same thing. Same idea. And then 7 is just also this thing. I probably could write this in a loop. I'm so tired, friends. Sorry if this is not quite what you're expecting. But yeah, but this basically has all the numbers, right? Or 9, I think I have to do an 1.9, so it's just this. And even then, I don't really have to do 1.9, other than like it's equal to 10 to the 9 or something. or something like that, right? And then now yeah, okay. I am not answering this in any meaningfully good way, because we still have to reverse all these things, because it's like getting a palindrome. Right now you have half of the palindrome, you have to get the other half. I am going nuts. And we still haven't even like calculated, you know, all these things. Right. Okay. So okay. So current is equal to 1 number of digits, right? Oh well, yes, 0 digits, and then you know, while current is less than equal to, I don't know. At the end, you current and a 10, and then maybe just digits is equal to 0, current is equal to 1, and then something like that, and then yeah. I'm just tired. I'm tired. I don't mind this poem, to be honest. But maybe just not the timing that I'm doing it on. For x in wad of digits, we basically just, you know, this is going to be 5 to the digits number of them. Well, 5 times to the number of digits minus 1 times 4, because the first digit has to be not 0. So yeah, okay. So count is, you know, something like this. It's 5 to the 9 anyway. 5 to 9 is a million. In theory, I could have done it that way, maybe. And 5 to the 8, right? Maybe I should have just done it that way, huh? It's 5 to the 8 is 39,000. I definitely did not take the easy way. But maybe I could go back and do it that way then. Okay. Almost like a breadth first search, 5 to the 8. Right, we can do it that way. Maybe, you know, okay, fine. Okay, yeah, let's do it that way. Maybe it's not too late to change. I believe in change. But yeah, sorry friends, I'm just so tired. But I am going to try to do basically a breadth first search. So Q is, maybe I could kept the middle and the thing. Yeah. Basically, Q is equal to collections.deck, right? Q.append. Let's just say for x in middle, right? Yeah, I mean, just right. Its count is equal to 0. Maybe that's the way that I should have done it. I don't know. But also in Leetcode, it might not be fast enough. But okay, so x is equal to q.pop left, right? if x is less than n or less than or equal to n, then increment by 1. Also, in that case, we will, that's not sufficient though. N good of x maybe, and we'll define good in a second. Otherwise, yeah, otherwise we just kind of, you know, and there's no idea of this thing anymore, I suppose. Right, and then basically, yeah, for y in R, q dot append x times 10 plus y, right? And that's pretty much it. As long as x is not 0, because then leading 0 stuff. Okay, I think that's actually good. And then now we can define good. Maybe I should have done it this way. Yeah, is that we rotate each digit, so okay, so then okay, for well, x is greater than 0, something like this, right? No, that's not good enough. That's not how you reverse stuff, is it? Take the yeah, no, it takes the smallest significant and then you convert it. We have to change this thing a little bit though, but yeah, so c is equal to y, and the thing is that if c is equal to 6, c is equal to 9, else if c is equal to 9, c is equal to 6. I'm just writing this in a really bad way, to be honest. So if this is not equal to x, then we're good. Middle is not defined. Okay, fine. I don't know what R means anymore, to be honest. But, why does this time out? For 20. Because basically this has to be for y. I mean, this gets bigger, right? So, oh, this part times out. Whoops. I am just so tired. It's a lot of analysis on this one. Okay, so I've definitely got it wrong, but we can at least see what they think good is. 25. So I'm doing more than they expect, so that's not good. Let's see if I'm double counting. No, I output 9. Did I misunderstand? 11. Oh, 11 is not good, right? What is what? Should also return 11. So I don't know. No, x is okay. Fine. Original x. So 11 is equal to 11. So why would it return that it is good? Dum, dum, dum. Though also we messed up here. I think the count one is it should be independent than the other one, because that's gonna mess me up later. But oh, damn it. Okay. I was even printing it, but then I don't know. All right, I mean, this looks good, but then let's just test a big case. Please, baby. That is very slow. I don't know that I can submit this 4.5 seconds. Yikes. But there are only 1.9 million things, so if we're really industrious, we can definitely cache it, and I think that's what I'm going to do. Because I am too tired to kind of do this in a slightly better way, to be frank. So yeah, so let's actually do something like, I think that's how, this is how you do it. I could be wrong. Like if I do not recommend this. I think the right way is just doing the counting thing, but I'm tired. It's Happy Chinese New Year, friends. So yeah. Oh, if this is good. And then we just binary search. Maybe bisect right? I don't know. I think bisect right, actually. Oh, is it? It's not self, right? It's something like that, maybe. I mean, it may take like 4 seconds, but at least after that, it'll be fast. Maybe. Oh, so, no, this is slow. Oops, I keep on forgetting. Yeah, so this is definitely still slow, but if we add another case, in another case, that's when the efficiency adds up. Maybe, I don't know if I'm implementing it quite right. This is like very Leetcode specific and kind of silly if you ask me. So maybe this times out. I mean, it doesn't time out, but it shouldn't. It's definitely also not reusing it, right? So I forget how to do it. It's just this. Maybe that was just a slow attempt. I don't know. Don't try this at home. I don't know. I just feel like I am a little bit lazy today. Well, I don't know. Maybe I'll redo this in the morning when I wake up, but for now it'll be okay. And just give it a submit, see what happens. I don't know that I'm happy about it, but actually apparently it still beats 45%. So maybe I don't know. I mean, I think I know how to do it, but the right way. It's just about a lot of counting, and then but there's so many possible silliness. Yeah, I don't know. I kind of just generate all the numbers and then binary search on it. You might have a better idea. I am too tired to kind of go over it. But this is just breadth-first search, right? I mean, I basically generate every. I mean, it's breadth-first search, but it's also just like generate every possible number. That is a good number, and then we kind of do this thing to check that it isn't. You could actually even do it in a smarter way, like I did generate it earlier, and then binary search on that. Maybe that would have been faster, but I'm tired. Sorry, friends. Let me know in the comments how you did it. So stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye, and happy Lunar New Year, happy Chinese New Year, happy New Year. Bye bye.